As one of the adventures Hawkeye has become well known in China, his magnificent skills in the movie attract more and more people to practice archery. Our quality project is archery performance improvement. Our aim is to help these beginner archers to master these skills quickly. To achieve that, we implement the DMAIC Six Sigma methodology, that is define, measure, analyze, improve, and control. In the define phase, we define the process as 30 arrows per test, which follows the common international competition standard. The objective of our project is to improve the performance of a beginner archer. How to define a good performance? Let's look at the video at first. To simplify the variants of the project, we have some variable controls. We use the same archer, the same arrows and ball, and the same field and target. It's difficult to evaluate a person's performance. Therefore, we divide the performance into two aspects, which is accuracy and precision. Accuracy is estimated by average score, while precision is estimated by standard deviation. Next, in the measure phase, we need to determine the performance standards and the measurement system. Possible independent variables can be archer distance, equipment, environment, training time, and shooting position. Along the whole project, we control the same archer, equipment, and environment, so we can study the distance, training time, MNI, and effective angle as our axis. Then we use the Pareto chart to plot out this text output, which can be shown as follow. Then we also use process capability index to establish the performance baseline so as to evaluate the process capabilities. Next, in the analysis phase, to find what factors influence the performance. Let's first look at 10 steps for archery. After brainstorming, we identified all the possible causes as shown in the fishbone diagram. We divide all the causes mainly into 4 groups: archer skills, equipment, and environment. Next comes the improve phase. In this part, we decide the experience to analyze the factors to the performance. We choose three factors of levels: distance, eye habit, and effective position. Then the Y is the average score of 5 suits. Then we use the Pareto chart to find the distance and the interaction of the distance and eye habit are 90% confidence factors. We check the residential plot to see if the model is reasonable. Since there's no apparent pattern for residential, this model fits well. From the effect analysis plot, we found the distance is the most important factor. All the factors have interaction with each other. Then we compare the performance before and after training in the same and improved condition. Relatively close to the target while aiming and middle position. We could see the permanent improvement of the performance. For demonstration, we'll show three sample sets. Here is the one sample from the first class, the second class, and the third class. We can easily tell that the performance has improved. Finally, in the control phase, since there's no subgroup data for our analysis, we choose IMR charts to see if the process is in control and to detect signs of special cases that might take the process out of control. We also compare the performance of the process at various stages, i.e., before and after carrying out the project. For the IMR chart of original, we found that the average score is smaller than lower bound and too many shows our limits. The MR is stable but low. The IMR chart of improvement told us that most points fall within the control limits. Meanwhile, the MR is good and stable. In conclusion, we found that the average performance has improved but still not stable enough. Therefore, the archers should put more efforts and time on training to get more consistent performance. This concludes our project. Hope you have enjoyed this. Thanks.